Welcome to Nokia 5G Talks, the professional podcast exploring Nokia technologies. In the last 5 years, the most commonly used technical terms are AI, cloud, IoT, cybersecurity, and 5G. And when we are talking about Nokia, we're probably most well known about the 5G technologies that we have. But what does it really mean? When you look at your phone, you can see the small 5G logo on the top of the corner. But do we really understand the difference between 4G and 5G? Why is the hype about? What does it really mean? And these are the questions that we would like to explore today in this episode of Nokia 5G Talks. Welcome everyone. My name is László Paksi. I'm leading a small development team here at Nokia. We are developing 4G, 5G cores which are targeted for the enterprise segment. And my partners in crime today, Zsolt and Gergő. Welcome, Zsolt and Gergő. Could you please briefly introduce yourself?
Welcome everybody. My name is Zsolt Szegedi and I lead a small team who is working in developing 5G private networks.
Hello, my name is Gergő Schiffler. I'm the responsibility of the Nokia Core Enterprise Solution as a program manager.
Thanks for coming. Just to ease up the whole situation, I know that this is not something that we are quite used to. I brought you a small game. The game that I call Guess the G. And the task is I will list a couple of technologies, features which are related to mobile networking and communications, and you have to guess which generation of mobile network introduced these features. Does it make sense?
Sure.
Yes.
Okay, cool. Let's start with which generation introduced YouTube and Skype?
3G.
Exactly, 3G. Good one. And which one was the first with SMS?
2G.
Absolutely. Okay, you know your you know your deals. Which one was the one that introduced the video streaming?
4G.
3G.
No, it was 4G. Okay, well, one miss. Which one was the first one with call security?
4G.
I can guess. Maybe 3G.
Actually, 2G already introduced some really basic security features. Okay, what about limited data?
3G.
4G.
2G, once again. 2G was quite good, I mean, amazingly. Which one was with the first one with applications for mobile phones?
3G.
3G?
See? Yeah, I think 3G.
Yeah, it was 3G, absolutely. And last but not least, mobile gaming.
You mean streaming?
Oh.
Yeah, like online gaming.
Online gaming. Okay.
Yeah.
4G.
Your guess?
I can guess. Yeah, maybe 4G. It's required for the latency. Maybe.
Yeah. So it was 4G. Mm-hmm. All of these technologies already exist up to 4G. So we have all of these amazing features, these technologies. So the big question comes, what 5G brings to the table?
In my view, and I think that's what people see in their everyday life is, of course, the bandwidth. So you can experience much better download speeds when you're watching videos on YouTube, when you're streaming a game, for example, and also a lot of things that people don't really see. And that's, I think, what we're going to talk a lot about in this episode. For me, I think the bandwidth is the most important for the everyday users.
Okay, so for everyday users is the bandwidth, but what about not everyday users? So creating a brand new technology just for bandwidth makes no sense.
Yeah, true. So for industrial users, which I think most of the people don't even think about it, that 5G can be useful for enterprises, for companies. Latency is one of the key features, the low levels of latency.
Okay. Can any of you explain what latency about? What does it really means?
Yeah, I think the latency is most importantly the in and out messages. So when the system is sending messages about the data, what they just want to provide, and also on the other side, the receiver and the time between the sent out and sending messages. So that's the latency, I guess, which needs to be very low to have a more precise data in the equipments or any other critical measurement or whatever is required for the very low latency. I mean, it's a kind of a precise.
Okay. Do you have any example in mind that can easily understood? So where latency is important, I mean, low latency is important.
Yeah, for example, the latencies of the automatic driving cars.
Okay.
Because when you are just trying to, let's say, drive these cars without a driver remotely, it's really important to let's say, to turn right and left the wheels to move in a right direction. So with a high latency, it cannot be done properly because maybe it can cause some issue.
Okay, so you're saying that due to the low latency of the 5G networks, self-automated or automated cars are more secure than not self-automated cars?
Yeah, definitely.
Do you know, by the way, what is the exact or, well, approximate value of latency in 5G?
I think in the milliseconds range.
Yeah, it's around 10 milliseconds. And just a fun fact, I don't know whether you know it or not, how much is the response time of a human being?
I think it's good if it's around 100 milliseconds.
Yeah, so a human being is like 150-ish, and the 5G reaction time is like below 10 milliseconds. So I think it's really impressive how fast the 5G network is capable to respond to stuff. So self-automated cars or automated cars, is there any other real-life usage of this latency? Why is it important?
I think it's very easy to understand if you think about mining. So there are these heavy machinery. We're talking about 30, 40 tons. Everybody saw those kind of machines, diggers, trucks with these huge wheels, people standing next to those huge wheels. And some of those devices are actually controlled via 5G because they are operating in environments that are dangerous for human beings to be there or to drive the vehicles, for example. And that's where the low latency of 5G networks come into picture. It's very important that when you're operating the machine from hundreds of meters or maybe kilometers away from the actual machine, then when you move the joystick, you need to be sure that the signal from the joystick to the actual machine should be there within milliseconds. Otherwise, it might happen that the machine will fall into a pit or you take a wrong turn and it rolls over, or any kind of incident can happen.
Okay, so people who used to play like Need for Speed or other car games in their childhood, now they benefit from these skills. Absolutely. Because they can use it in real life. But how does it work? I mean, how do you control or move a truck or any kind of machinery with 5G? How does it work?
Basically, like for your normal mobile phone, you need a SIM card. It can be a physical SIM, it can be an eSIM. Obviously, these trucks and machines are not prepared by default as they come out from the factory to get a SIM card or to be able to host a SIM card. So you might need some special devices. We call them 5G field routers or dongles. These are the equipment that actually host the SIM cards. So they provide the connection to the 5G private network or public network even. And then these dongles or field routers are connected to the machines, proper interfaces, so you can then control the machines via these equipment.
So basically you just have a USB stick, you plug it into the car or the device and it's going.
Pretty much.
Awesome. So we already talked about latency, which is really a key factor for most of the use cases. Is there any other feature which is beneficial for enterprises or industries?
Yeah, definitely. I think the reliability and the security.
What do you mean by that?
The reliability is just kind of in that industries or in that cases where we just try to use the capabilities of the 5G. We need to, let's say, make sure everything is working properly fine in a lot of 9%. 6, maybe 7 is more or less what is acceptable from the customer perspective. So definitely we need to make sure everything is working correctly without any outage. And that means reliability. And here I think what we can provide to our customers in Nokia, it's really compliant with that requirements. So our CNFs and our softwares and platforms can, let's say, provide those reliable numbers. What does the outage means? That means it's only 1 minute in 1 year. So that's what we need to provide to our customers, because this is the requirement from their side. And also it's a kind of a requirement from their customers, like the people in the world who is using their equipment and the networks what they can provide.
But why is it a requirement? So why is it so important to have such reliable systems? Who's using these systems, or why cannot we allow any downtime?
You can think about mission critical applications.
Okay.
For example, like firefighters, police, who absolutely need to rely on these systems in order to be able to act when there's an issue, when there's a problem. And also the mining example comes to mind again, that the customers cannot allow or afford that these machines are not working 24/7 because they are very expensive. They are rented in some cases from other companies, and it's a huge business impact if you out of business or production for, let's say, hours instead of minutes or continuous production.
Okay, oh, that makes sense. Gergő, you also mentioned that besides reliability, security is also very important for 5G networks, and how and why 5G networks are secure.
It's mainly for the provisioning. So in the Nokia networks, there are SIM cards what you need to use for your equipments to be able to connect to the network itself. And with the SIM cards, you can, let's say, have a secure provisioning process, and that can be the best option to have a secure network.
Mm-hmm. Okay, so basically you have absolute control over who's and how using the network.
Yeah, exactly.
Okay, that's really a great feature. So we have reliability, we have low latency. What else is to 5G networks?
Scalability, I would say. So imagine that you have big public events like sports events or concerts, whatever. You need to scale your network very quickly to react to that dynamic growth of users in a single place. And 5G networks are absolutely capable to do so. So they are very easy to scale up, especially if it's combined with some cloud technology, then operators are able to scale up very quickly.
Do we have any numbers, like what scalability means? How many users can be served with the 5G network?
It very much depends on the configuration of the operator. And it also depends if you're talking about a public network or a private network. In public networks, as you probably know, usually every country there are at least 3-4 operators providing service. You can take the ballpark figure that there are 1.2 phones per person in that country, and those 3 operators should cover that amount of devices. So if you take the US, for example, we can assume 400 million subscribers ran by or serviced by 3 operators. So that's in the 100 million figures. And then, of course, if you go down to the cell level, in 5G, the cells need to be very small in order to provide this huge bandwidth that we talked about and all the low latency and all the benefits we talked about. But with small cells come the limitation of low amount of users. So that's why you need to be able to scale when a lot of people are in one place suddenly. I think everyone from the podcast listeners experience that when they go to such venue, they can experience some disruption in the service, or at least slower data, for example.
So we discussed the main benefits of 5G, so latency, reliability, and scalability. And you've been working for Nokia for quite some times now, and you've been working with the enterprise cores and the enterprise solutions. So what are your favorite use cases? Why 5G networks are cool on the field?
My job is mainly related to enterprise customers. So And my favorite use cases also come from, or benefits also come from the enterprise world, because I think it's easier to see how 5G can change how enterprises can operate. One of my favorite use cases is so-called 5G precise positioning that my team works on. So this feature, as the name suggests, we use 5G to position the location of user equipment with high precision, around 1 meter, either indoor or outdoor. So basically you don't need anything else, you don't need GPS, you don't need Bluetooth or any other technology to be able to locate these end user devices. Just the 5G network, just the equipment with the SIM card. And then the network will be able to tell with around 1 meter accuracy where that device is within that location or venue. There can be many use cases for this technology. One of my favorite projects that we work on is in a prison, actually, in Europe, where we use this 5G precise positioning technology to locate the guards within the prison and to see how they move compared to their normal daily routine. So all these guards have their predefined routes, how they should go around the prison and check on each prisoner. And if, based on their location calculated by the network, if we see any deviation from that normal route, then we can send someone there to check if anything happened. Maybe the guard fell or someone attacked him or something like that, and then this can be automatically and easily detected.
Cool. Gergő?
My favorite 5G use case in Nokia was on last year, when the main focus of the project was to, let's say, to provide the bubble, a kind of a radio coverage, and test it and measure some KPIs. Okay. But the most interesting part was the place of this exercise, because we were in the big area outside of this office, of this building. And we tested this radio coverage, this radio bubble, with cars, with drones. So we provided the core solution, we provided the radio setup, we provided the user equipments with mission critical softwares. And also the two use cases, what we, let's say, demonstrated there, was the first one when the radio equipment is on the ground. So, and that means the radio coverage was much smaller than when we put this radio equipment into to the drone, and we flew up at 30-meter height.
Okay, so you basically went to the middle of nowhere, carried the radio and the small unit, and you basically created a fully functioning 5G network.
Yes, exactly.
Controlling everything.
Yeah, and we tested with cars, and I mean, in a first use case, we move around the cars and measure the KPIs, and definitely we lost the signal when we ran out of the radio coverage, when the radio was on the ground. And after that, when the drone was in the sky at 30-meter height, the radio coverage was much bigger. We can move far in the area. And how the main goal was this? So what was the main goal of this demonstration is to how this bubble can be easy to set up, how this network was easy to kind of use, because it was kind of required 2 hours to set up the whole end-to-end network, and it worked well.
I think it's really a cool use case.
Yeah, definitely. It was a whole day. It was a whole day story. I mean, from the very beginning of the day to the late night. So yeah, because it required a lot of preparation and it required a lot of, let's say, additional works after the demonstration. I mean, for example, maybe the most funny part was the using the generator to generate electricity. and I need to move to the petrol station by 2 hours just to fill again.
Adventures and adventures.
Yeah.
Nice.
Yeah, but it was a really good experience. I really liked that project. By the way, it was successful. So
thank you for sharing these experiences or these use cases. I think it was really, or it made it obvious that there is more to 5G that meets the eye. It's definitely more than just the logo on the top of your mobile screen. So thanks for joining for this episode, and thank you for your inputs and your experiences.
Thank you very much for the opportunity.
thank you so much.
Thank you everyone for listening to this episode of Nokia Talks, Nokia 5G Talks, and tune up for the other episodes and follow us on social media. Thank you for listening to Nokia 5G Talks. Check out other episodes and exploring Nokia technologies.